Assalamualaikum warahmatullahi wabarakatuh and good morning everyone.
Waalaikumsalam, Miss.
Good morning, Miss. Good morning, Miss.
Good morning. Ada 55 orang je Bila saya start je. Okay. Hari ni kita akan masuk a new chapter number 8 called hydroxy compounds. So under this hydroxy compounds, we have 5 subtopics altogether. The first one is nomenclature, basically naming of hydroxy compound, alcohol. And then we have the physical properties. Physical properties tu boiling point, solubility. Okay, lepas tu 8.3 is the preparations of alcohol itself. So bila sebut preparations of alcohol ni, we want to prepare the alcohol from other organic compound. Okay, lepas tu kita pun ada chemical properties. This chemical properties is for hydroxy compound. And lastly is for phenol. Okay, for the first 4 subtopics, they will mainly on aliphatic alcohol. Aliphatic alcohol ni maksudnya alkohol yang open chain dan cyclic structure. Dia bukannya yang aromatic. Okay, starting from 8.5 phenol barulah kita akan tengok yang aromatic. Alright, so for the first part, nomenclature of alcohol. So nomenclature of alcohol ni naming of compound sahaja. So kita tengok dulu basic dia. Your alcohol should have hydroxyl group. Hydroxyl group hanyalah OH bonded to sp3 hybridized carbon atom. Maksudnya ada 4 bond keliling carbon. Okay, so cuba kita try this compound for aliphatic and aromatic alcohol. Okay, kalau aliphatic, you have this open chain or cyclic structure yang bukan aromatic. Could you please tell me what is the name of this compound? Kita akan apply IUPAC system yang sama. Look for the longest parent chain. Berapa banyak carbon? 5. So nama dia akan jadi, kalau sekali dengan suffix ni, kita akan guna all. Ya, pentanol. Okay, should we put number for this pentanol or we simply say it as pentanol?
Number.
Yes, sebab kita sekarang ni kita ada functional group. Bila functional group macam ni, awak ada possibility untuk form positional isomers. Maksudnya it can be on carbon number 2 and carbon number 3 untuk case ni lah. Kalau sini dengan sini dia jadi 1 dengan 2 sama. Okay, the numbering will start from the functional group present and then here we have 2 apa? Methyl. So the name gonna be 2-methyl 1-pentanol. Okay, and then we have this aromatic alcohol, means we're gonna have the benzene ring. Okay, the benzene ring now, we have learned about chapter 6, the benzene ring, got monosubstituted benzene, disubstituted benzene dan juga trisubstituted benzene. Okay, jadi sekarang ni kita ada case untuk disubstituted benzene. Apa yang awak ingat tentang naming the disubstituted benzene? Yes, kalau disubstituted benzene, kita ada buat apa je? Ada tak beza sikit? Ada. Kita buat apa dah yang beza sikit tu?
Boleh letak like ortho.
Sorry?
Boleh letak like O or M.
Yeah, the O, M, O, P tu adalah prefix. That prefix belongs to apa? Bilangan or locations?
Position.
Yeah, position. So now, what kind of combinations do you have for this one? For CH3 dengan OH?
1-2.
1-2. Kalau 1-2 kita akan guna?
Auto.
Okay.
For that one only can use for kalau sama ke?
Boleh. Kalau lain pun boleh.
Okay.
Same boleh, lain boleh. Cumanya you kena letak dia depan lah kalau dia substituent. Okay, you have 2 substituents now. It can be the same, it can be the different. Okay, tapi case ni selalunya kita tengok. Kalau different pun tengok pula dia punya priority. Kalau nak naming, kena tengok alphabet. But if you have one of them got important functional group on them, jadi the numbering should always start from there. Okay. So sekarang ni siapa yang kita nak letak nombor 1? OH or CH3?
OH.
OH. Jadi, boleh tak saya tahu apa common name untuk benzene directly attached to it is the OH group?
Phenol.
Phenol. Okay, so how do you call this compound? Kalau kita guna, kita letak nama dia phenol.
2-methyl-phenol.
2-methyl-phenol. So kita ada 2-methyl-phenol, tak perlu letak 1-phenol. Awak juga boleh guna auto-methyl-phenol. Okay, sebab dia combinations of number. Dia tak kisah difference kat situ pun boleh guna juga. Alright. Next one, kita dah tahu itu tadi untuk kita letak OH dekat carbon number 1. Okay, you must bear in mind the carbon bearing the OH also got its classes. Classes yang macam mana? Macam awak classify carbon, macam awak classify alkyl halide. But one of the bond already been taken by the OH group. Jadi kita tinggal sampai 3 sajalah. So we have primary alcohol, secondary alcohol and tertiary alcohol. Bila kita ada classes of alcohol, kita boleh ada positional isomer. That's why when naming a compound, you should always put the positions for your suffix. Selalunya prefix saja. Sekarang ni suffix boleh buat positional isomer, kena letak nombor juga. Okay, try naming this compound. The longest carbon chain belongs to
Hexane.
hexane. The numbering starts from the left or from the right?
Left.
From the left. Okay.
Left.
Left sebab apa kita ambil left?
OH is closer.
Yes, OH is closer.
Functional
And even
group.
kalau sini pun awak jumpa yang ni the other end dulu. Okay, so what is the name of this compound?
Ethyl.
Okay, where is the ethyl
Ethyl.
located? Carbon number 3 or carbon number 4?
3.
3. So nama dia 3-ethyl only for your substituent. Your parent belongs to hexane.
Number
But then since you have this OH as an important functional group attached to carbon number 2, what is your parent and family name?
Hexanol.
Hexanol, but the OH is located at which carbon?
2.
2. So the name should be
2-hexanol.
2-hexanol ataupun you can use hexan 2-ol. Okay, so 3-ethyl 2-hexanol. Right, itu sebab dah melibatkan classes lah. Can I know what is the class of alcohol for this compound? If they are attached to 2 alkyl group?
Secondary.
Secondary. Okay, good.
Secondary.
Okay, now, do we have aliphatic or aromatic alcohol?
Aromatic.
Is this a compound obey all the 4 criteria of aromaticity?
No.
No. So, bila dia tak obey all 4 criteria of aromaticity, dia bukan aromatic compound. Dia belongs to
Aliphatic.
aliphatic only. Aliphatic kan, awak kena tahu beza aliphatic dengan aromatic sebab chemical properties untuk aliphatic and aromatic berlainan. Identification test untuk aromatic and aliphatic berlainan. Okay, jadi tak boleh tertukar. Kena check the criteria of aromaticity. Okay, who's gonna be our parent and family? Do you think the longest carbon chain?
Pentanol.
Pentanol. Okay. So sekarang ni, bila kita dalam cyclic structure, you have to put number. Okay, you have to put number. Okay, usually kalau dalam benzene, kita tengok hujung ke hujung macam tu lah. Kan? Right, tapi sekarang ni awak tengok balik. Bila you ada important functional group, you must prioritize the numbering from this functional group. Maksudnya OH walaupun duduk tengah, dia kena jadi carbon nombor 1. Lepas tu kita tengok combination dia akan sama tau. If you pusing kanan, 1, 2, 3, 4, 5. 1, 2 and 5. If you pusing kiri, 1, 2, 3, 4, 5. Also 5 juga. Jadi kita tengok apa pula kita punya kriteria untuk naming dia.
Alphabet.
Alphabet. So who comes first, bromo or methyl?
Bromo.
Bromo. So kita akan start dengan numbering bromo lah, ke arah bromo. Jadi what is the name of this compound?
2-bromo-5-methyl cyclopentanol.
Yes. Do we have to put 1 cyclopentanol?
Tak.
Tak perlu. Okay, tak perlu sebab dia automatic nombor 1. Okay, right. Thank you. Right. Okay. Next one, kita ada this time, kita ada branch alkyl group. Nak tengok awak still remember or not. So the longest carbon chain gonna be how many carbons?
7.
7. So the name gonna be heptane. So the numbering will start from the right or from the left. Look for the lowest combinations of number.
Right.
From the right. So could you please tell me what are the substituents present? Ikut turutan nak naming. Tengok siap-siap alfabet. Kalau ada. Substituent apa yang kita ada dalam ni? So we have to for
Isomethyl.
yes, for isopropyl ataupun boleh guna for methyl ethyl. Okay. Lepas tu kita ada parent kita siapa? Together with the suffix tu? Parent and family?
Heptanol.
Okay, look at the family OH. Kat mana dia duduk? Boleh ke
2 heptanol.
2 heptanol. So the name of this compound is 4-isopropyl 2-heptanol. Okay, next one. Yang ni kita ada case apa pula? Who's got greater priorities in terms of your suffix? Siapa yang akan jadi family dalam ni? Alcohol or benzene? Alcohol. So the numbering will start from the right or from the left?
From the left.
From the left. Kita tengok. From the left ke from the right? 1, 4, 5. 1, 4. Kita ada 1, 4 ataupun 3.
Right.
From the right wak. Sebab yang ni carbon number 1, 2, 3, 4, 5, 6. So kita ada combinations of 3 and 6, right? Kalau dari kiri, kalau dari kanan 1, 2, 3, 4. 1 and 4. So kita akan start daripada kanan. Okay, so we have 2 substituents here. Okay, 2 substituents as in the prefix. Okay, we have at carbon number 1 and carbon number 4. At carbon number 1, what is the name of this alkyl group? Or what is the name of the substituent? Sorry.
1-phenol.
1-phenol. What about the number 4?
4-chloro.
So siapa yang patut dinamakan dulu?
4-chloro.
Chloro.
4-chloro, 1-phenol. What about your parent and family?
1,5-hexanediol.
Okay, you have 2 OH, right? Bila kita ada OH sahaja kita panggil all. Okay, bila kita ada 2 OH kita akan tambah prefix. Prefix kalau 2 kita guna di. So nama dia
hexanediol.
Yes, hexanediol ataupun hexane 1,5-diol. Okay, boleh guna dua-dua. 4-chloro, 1-phenol, hexane 1,5-diol ataupun 1,5-hexanediol. Okay, habis untuk nomenclature. So awak tengok sikit lah bila aliphatic compound lain, dia punya cara nak naming and numbering. Always dia stick pada rules yang sama, tapi kena hati-hati jugalah bila ada important functional group yang higher priority ni. Okay, second one, we have physical properties. So physical properties usually kita nak tengok lah how about its boiling point in terms of solubility. So sekarang ni kita akan fokus pada aliphatic alcohol. So aliphatic alcohol ni yang open chain ataupun cyclic structure, the boiling point dia akan tengok molecular weight. Okay, molecular weight sama juga macam alkene. Bila molecular weight tinggi, strength of van der Waals forces pun bertambah. And then boiling point pun will increase. Okay, lepas tu kalau compound of comparable molecular size yang sama cuma ada branching, stronger intermolecular forces dan higher boiling point. Oh, also bear in mind, alcohol juga can form hydrogen bond. Okay, boleh buat hydrogen bond juga. Okay, for example, we have this compound. Here we got 1, 2, 3, 4 carbons. Here we have 1, 2, and 3 carbons. Here 1, 2, 3, 4. 4 carbons. Okay, adakah diorang semuanya alkohol?
No. No.
Ada kan?
Tak.
No. So the far right here, can I know the class of compound when you have OH?
Primary.
Okay, primary apa?
Alcohol.
Alcohol. Okay, yang ni kalau kita ada COC, if we have COC,
Ether.
either, betul. Kalau kita ada C and C only and also H,
Alkane.
alkane. So, bila kita nak discuss about boiling point, okay, you kena tengok intermolecular forces present. Now dia dah start bagi different classes of compound. Okay, intermolecular forces again, kita ada hydrogen bond, London forces dan juga dipole forces. Okay, who do you think gonna have the highest bonding point? Alkane, alcohol or ether?
Alcohol.
Alcohol. Sebab apa kita pilih alcohol? Dia boleh buat apa?
Hydrogen bond.
Yes, hydrogen bond. The next, bawah daripada alcohol. Alkane or ether?
Ether.
Ether. Ether boleh buat apa? Ether boleh buat apa? COC tengok.
London forces.
London forces between non-polar and non-polar. Now look at your ether. You have C in group 14. You have O in group 16. Do they have difference in terms of electronegativity?
Yes.
Yes.
Bila ada difference in terms of electronegativity, kita akan ada bond jenis apa? Polar or non-polar?
Non-polar.
Polar.
Dipole.
Yes. Tunggu. Saya tak habis. So differences, bila ada difference in terms of electronegativity, kita akan ada polar bond. So maksudnya ether ni is a polar molecule. Bila polar molecule dengan polar molecule buat interactions between themselves, dia akan form dipole interactions which has greater strength than the alkene. Okay, sebab alkene awak walaupun ada 4 carbon tetapi molecular size dia lebih besar sebab oksigen awak lebih besar. Okay, so kita tahu dalamnya ada London forces and dipole, and for alcohol we have all of them. Okay, jadi the trend will be like this, increasing from alkane to ether to alcohol. Okay, so how do we explain about these intermolecular forces? Bagi tahulah the highest should be alcohol. Okay, kenapa kita kata the highest should be alcohol? Sebab dia ada polar bond, dia polar molecule lah dan dia boleh buat hydrogen bond. Itu untuk alkohol saja. So kalau untuk these two, awak sambung lah, saya tak cerita kod series. Yang ni kita cakap pasal dipole dengan London forces which one is greater. Alright. Next one kita akan proceed with solubility. Okay, solubility of alcohol. Do you think alcohol will dissolve in water?
Yes.
Adakah semua alkohol akan dissolve in water?
No.
Kenapa awak cakap alcohol in general, kenapa dia boleh dissolve in water?
Sebab boleh form hydrogen bond.
Yes, betul. Alcohol in general can form hydrogen bond tapi bukan semua alcohol boleh dissolve completely in water. Okay, jadi kita akan tengok alcohol jenis apa yang tak boleh tu. Right, so if you have alcohol with carbon less than or equal to 5, okay, they are capable to form hydrogen bond with the water. But if you have more than that, okay, dia akan become insoluble lah, bukanlah insoluble, slightly macam susah lah dia nak dissolve, slightly soluble, stuff like that sebabnya size of your carbon lagi besar daripada your OH, so dia tak boleh nak menampung. Okay, dia ada limit dia juga. So dia bagi dalam 5 carbon, okay, itu maksimum dia boleh buat dengan satu water molecule contoh. Kalau dah lebih pada tu, maksudnya dia ada satu part yang kita panggil hydrophobic, dia phobia dengan air. Bila dia phobia dengan air, dia tak nak dissolve. Okay, ni contohnya lah. Okay. Mana dia punya gambar? Di sebelah kot. The solubility of alcohol in water gradually decrease as the hydrocarbon portions of the molecule lengthen sebab hydrophobic area ni. Saya tahu kot awak pernah tengok rasanya hydrophobic area yang ni, yang macam apa kita belajar dulu kat bio, yang membrane tu, ingat tak? Ada hydrophobic region.
Ada miss.
So yang itulah. Okay. Sebab dia tak boleh panjang sangat. Lebih pada 5, macam 6, 7 tu over sangat, dia tak boleh nak tampung. Dia punya OH ni tak capable untuk buat banyak hydrogen bond dah. Okay, right. next kita proceed to 8.3. So 8.3 is about preparations of alcohol. Basically reaction lah, but we want to prepare the alcohol from something else. Okay, so preparations of alcohol got 4 reactions altogether. The first one we have fermentation. So fermentation ni adalah a biological process of enzymatic degradations of sugar by microorganism. Ni awak pernah belajar dekat dalam bio. Ni awak hafal je lah, kita tak ada melibatkan. Awak kena tahu reaction ni, cumanya dia biological process, dia bukannya yang kita selalu buat tu. Okay, lepas tu kita ada hydrations of alkene. So hydrations of alkene, kita dah pernah jumpa belum reaction ni?
Pernah.
Pernah dekat dalam chapter?
5.
Chapter 5. So untuk hydrations of alkene, awak kena ada apa selain air? Hydrations, you want to add water, but apart from water, do you need something else? You know alkene? Yes, kita nak buat apa?
Catalyst.
The catalyst, H3O+, okay? So awak kena letak alkene to react with water together with the conditions here, dia guna acid catalyst to finally form your alcohol. Okay, now can I know what is the name of rule used to determine whether hydrogen or OH to be added to which carbon? Kita nak guna rules apa?
Markov-Nikov.
Yes, Markov-Nikov. Right, And then hydrolysis of haloalkane. Kita dah jumpa belum hydrolysis of haloalkane?
Yes.
Yes, hydrolysis again you want to add water. Okay, hydrolysis of haloalkane kita dah jumpa dalam chapter 7. You initially got your alkyl halide or haloalkane to react with it can be either kenapa dekat sini? It can be either water ataupun hydroxide ion. Okay, satu strong nucleophile, satu weak nucleophile. Last sekali akan dapat produk yang sama, ROH. Dan juga your side product of halide, halogen dan jadi negative charge. Okay, and last one, additions of Grignard reagents to carbonyl compound. Yang ni dah belajar belum?
Dah.
So preparations of alcohol basically the same reactions as you have learned in chapter 5 and chapter 7. Okay, kalau perasan, chapter 7 sangat banyak akan jumpa balik. Okay, sebab dia melibatkan carbon and halogen. Very high difference in terms of electronegativity makes the halogen a good living group. Jadi sebab tu dia selalu jadi perantara nak jadi benda lain. So additions of Grignard reagents to carbonyl compounds, dia nak hasilkan apa? Kalau kita add Grignard reagent ke carbonyl compound, awak nak hasilkan apa? Adakah satu jenis alkohol sahaja? Type of alcohol to be formed from the additions of Grignard reagent to carbonyl compounds will form only one type of alcohol or 2 or 3?
More than 1.
More than one, iaitu primary, secondary and tertiary lah kan?
Yeah.
Boleh tak saya tahu, if you want to form secondary alcohol, okay, secondary alcohol, the Grignard reagent should react with which carbonyl compound?
Aldehyde.
Aldehyde. Can you please tell me what is the name of aldehyde yang kita dah boleh start guna? Can you take the aldehyde with only one carbon to form secondary alcohol?
Cannot.
Cannot. Okay, sebab secondary alcohol nak 2 alkyl group. Jadi satu datang pada Grignard, satu lagi mesti dari aldehyde dia. So untuk form secondary alcohol, aldehyde to be used mesti start daripada 2 carbon, iaitu ethanol. Okay, so benda ni saya ambil basically kalau awak react dengan aldehyde dapatlah primary or secondary. If you react with ketone, you will get tertiary. Right, Okay, next one, 8.4, chemical properties. Okay, chemical properties here, dia nak cerita pasal reactions yang ada pada alcohol, specifically on the OH. Okay, saya nak terangkan yang chemical properties of alcohol can be divided into 2. Okay, satu alcohol sebagai acid, Satu lagi alcohol sebagai base. Bila dia kata as an acid, when the reactions happen, they will take only hydrogen, left the O minus dekat dalam compound tu. Kalau dia bertindak sebagai OH, dia akan ambil OH tu. Okay. Jadi, alcohol as an acid, kita ada dua reactions. One is reactions with sodium metal. Another one is reactions of esterification. Kita nak form ester. Lepas tu, as a base, there are three reactions altogether. We have first dehydrations of alcohol, formations of haloalkane via substitutions, and lastly oxidations reaction. So kena faham terbahagi kepada dua. Sebab satu ni kita ambil H sahaja. Remove the H, buat produk baru. Kalau as a base, remove the OH, buat produk baru. Okay. Kita akan tengok alcohol as an acid dulu. H+, dia akan remove H+. Okay. As for reactions with sodium, okay, sodium yang kita cakap hanyalah sodium metal, Na sahaja. Okay. Bila awak reactkan the reactant, the alcohol and also the sodium metal, okay, you will form sodium alkoxide and hydrogen gas. Okay. Awak tahu Na is metal, O is non-metal. Jadi dia tak akan buat bond. Dia hanya akan buat macam salt. Okay. O negative and A plus. Dia kena dekat. Your R here is your alkyl group. So this is what we call sodium alkoxide. And then plus, we have only one hydrogen. But you want to form the hydrogen gas. So you need to put 1/2 before the hydrogen gas. And if you look here, you have this arrow pointing upwards. It tells you about gas being released. Okay, kena tunjuk benda ni. Kalau awak tak tunjuk yang ni, awak kena buat dalam kurungan gas, bagi tahu state dia. Kalau mendap ke bawah, solid ataupun buat arrow ke bawah, precipitate lah. Boleh reactions yang first, saya tak tengok detail maksudnya saya tak tengok contoh yang spesifik. Saya hanya guna this general equation sahaja.
Okay.
Okay. Bear in mind, reaction yang kita tengah discuss in 8.4 ni untuk aliphatic alcohol sahaja, okay? Sebab dalam 8.5 ada yang untuk aromatic. Okay, and then we have esterifications. We want to form ester. Ester functional group is carboalkoxy. You have the carbonyl group C double bond O together with OOC. Okay, maksudnya you akan react dengan carboxylic acid. Okay, so the reactant you starts with the alcohol from this chapter, and then kita akan react with carboxylic acid. Bila you dah react carboxylic acid, maksudnya nanti reactions yang sama kita akan tengok juga dalam chapter carboxylic acid. Okay, we want to keep this C double bond OR in blue, and then want to keep the RO in here. Means sebab dia act as an acid, dia akan remove only the hydrogen kat sini. Dia akan remove hydrogen dia sekejap lagi nak dapat produk. Okay, the conditions for esterifications, you must use this reversible arrow, and then we have the acid catalyst H+, and you can use heat or reflux, okay, sebagai support kepada this acid catalyst. And lastly, kita akan pecahkan bond ni, kita akan remove hydrogen daripada alcohol, and then we got our ester and water. Okay, ester ni dia wangi. Okay, dia selalunya kalau perfume ke apa tu ester lah. Alright, nanti awak tengoklah nota cakap pasal applications pun awak kena tahu sebab sometimes soalan dia bagi awak statement tentang applications. Okay, saya nak fokus pada the reaction sahaja. Nanti awak tengok balik nota. Okay, itu dua reactions alcohol as an acid. Okay, now alcohol as a base, kita akan remove OH untuk buat compound baru. Dehydrations of alcohol dalam chapter, kita dah jumpa belum? Dehydrations, eliminations?
Dah.
Dalam chapter 5, kita prepare alkene. So, samalah juga. Kita nak prepare alkene. So, we start with alcohol. And then the same conditions where we have concentrated H2SO4 and heat. And then you will get your double bond. Can I know what is the name of rule used to determine major product in alkene?
Zev's rule.
Zev's rule, okay. Next, we have substitutions reaction using HX, PX3, PCl5 or SOCl2. Hanya nucleophile ini sahaja. Okay, kita ada nucleophilic substitution berlaku dekat sini. kita nak hasilkan haloalkane. Okay, haloalkane kita tahu yang hari tu kita belajar nucleophilic substitutions kita ada melibatkan OH. Okay. Tapi itu satu je OH yang awak guna. Untuk dalam chapter 8 ni, kita akan ada lebih pada satu nucleophile boleh dapatkan haloalkane. Dia tak sama lah, dia sama tak sama sebab reaktiviti dia tak berapa sama. Okay, so for the first one, kita akan react dengan HX. You simply replace the OH with your X and then you will get your side product of water. If you react with this PX3, maksud X3 ni, it can be either Cl or Br lah. Okay, kita akan dapatkan RX H3PO3. Kiranya produk ni sama, just replace the OH and X, tetapi kat sini dia berlainan, dia side product. And then if we react them with PCl5, we will get this RCl together with the side product of POCl3 and HCl. Ni nak nafas sikit. Kita tak guna PBr5 kan, sebab tu dia dah spesifik PCl5. Okay, and then we have this ROH to react with SOCl2 with pyridine. Okay, pyridine kena ada. Pyridine diperlukan untuk buat reactions dengan SOCl2. You will still substitute only one of the Cl here and then the rest akan jadi dia punya side product. So ini adalah reactions untuk nucleophilic substitutions. You just kena hafal ni sikit lah. Okay, and last one is oxidations. Okay, oxidation, before this we have learned in chapter 5, we have oxidative cleavage. Kita ada KMnO4, H+, and heat. Itu kiranya oxidizing agent lah. Okay, lagi apa? Ozonolysis tu bukan. Lagi apa awak jumpa? Awak baru jumpa KMnO4 kan? Okay, sebenarnya kita ada more than one oxidizing agent. So, you can use this acidified solutions of chromate. Okay, ni cara tulis dia. Boleh pilih salah satu. Tak kisah. Tak payah tulis semua sekaligus. Pilih salah satu. Okay, Na2CR2O7 together with H+ and heat lah. Conditions masih sama. Ni oxidizing agent sahaja. We have these acidified solutions of permanganate, the KMnO4H+ together with heat. Okay. And lastly, we have this pyridinium chlorochromate. So kita panggil PCC sahaja. Kalau awak kena buat reaction, PCC sahaja. Okay, PCC tetapi kena letak solvent in CH2Cl2. Cara tulis penuh dia. PCC in CH2Cl2 tak perlu heat, tak perlu H+. Okay, so sekarang ni dalam banyak-banyak oxidizing agent ni, kita ada dia punya strength of oxidizing agent juga. Okay, the first two belongs to strong oxidizing agent. Okay, bila cakap strong oxidizing agent, maybe waktu dia buat reactions tu dia boleh penetrate sampai habis. Contohnya, daripada alkohol boleh jadi aldehyde. Tapi kalau strong, daripada alkohol boleh terus jadi carboxylic acid. Okay, aim oxidizing agent ni nak masukkan oksigen. So dari alkohol jadi aldehyde ke apa, nak double bond and stuff lah. Kita tak perlu tahu the mechanism, but dia involve a number of reactions. While for pyridinium chlorochromate, the PCC in CH2Cl2, they are considered mild oxidizing agent. Bila mild, bila dia attack sekali tu mungkin takat tu je. Mungkin dia tak sesuai dengan keadaan reactions tu. Sebab tu dia bagi mild reaction sahaja. Awak kena tahu strong and mild and then classes of alcohol sebab oxidation's product will depend on the class of alcohol and also its type of oxidizing agent. Dia bukannya hafal yang ni dapat yang tu, hafal yang ni dapat yang tu. Kena tengok dia ni alkohol jenis apa. Kita guna oxidizing agent apa, baru boleh tentukan dia dapat produk apa. Okay?
Alright.
Okay. So kita akan tengok one by one. Since we have 3 classes of alcohol, we're going to look at these oxidations of primary alcohol by using all 3 oxidizing agent. Okay, if we react them with either one of the chromate agent, the acidified chromate, kita akan dapat carboxylic acid. Okay, sebab apa kita dapat carboxylic acid? Asalnya awak ada satu O. Lepas tu awak ada 2. Lepas tu awak ada sini single bond, double bond. Maksudnya ada a few steps yang awak buat. Okay, sebab apa? Sebab dia ni strong, dia boleh dapat sampai last sekali carboxylic acid. Kuat lah. If we react them with KMnO4H+ and heat, awak rasa dia akan dapat apa? Dia kuat ke mild? Strong or mild, the KMnO4?
Strong.
Dia The carbenophore is strong, so you expect to have product of?
Carboxylic acid.
Yes, carboxylic acid. Okay, good. And lastly, PCC. PCC in CH2Cl2 is a mild oxidizing agent. So, kita tak boleh expect dia dapat carboxylic acid. Okay, kita kena expect dia dapat only aldehyde. Okay, only aldehyde. Maksudnya, dia buat macam, maybe dia buat eliminations dekat sini ke supaya dapat double bond. Kan? So, setakat tu je dia tak boleh sampai habis, sampai tukarkan semua. Sebab kita still ada the H ni, dia masih reaktif. So sepatutnya dia boleh masuk lagi. Okay, for secondary alcohol now, you have 2 alkyl group attached to it. Okay, so you must consider when they do the oxidations, yang hanya akan berubah, yang mainly akan berubah adalah yang ada O. Okay, kita tahu dia akan berubah. Macam tadi kita dapat double bond, so we must expect we got double bond. Okay, bila kita ada alkyl group, diorang ni susah untuk kita pecahkan as compared to hydrogen. Bukanlah susah untuk pecah, untuk buat react dengan dia. Okay, jadi you must expect that all 3 oxidizing agent will give you exactly the same product, which is ketone. Okay, sebab apa? Sebab tempat untuk kita buat reaction dah tinggal satu ni sahaja. H ni memang ada tapi dia tak akan kita tukar. Sebab kita nak buat oxidation agent ni, oxidation ni kita kena form this carbon double bond O. So the CH ni kena remain sahaja sebab kita akan dapatkan double bond tu. Okay, sebab apa dia jadi ketone semua? Sebab kita ada 2 R tepi ni. Once dapat double bond, jadilah ketone. Tak kisahlah strong or mild. Okay. Ni untuk secondary alcohol.
Alright.
Right. Lastly, for tertiary alcohol. For tertiary alcohol, what kind of product to be formed, do you think? Can we form any double bond between carbon and oxygen?
No.
No.
No. So, untuk semua pun tak dapat reaction sebab oxidizing agent tu tak dapat nak buat apa-apa sebab dia dah penuh. Okay, dia ada steric hindrance kat sini, great steric hindrance. Tak boleh nak buat reaction, nak pecahkan sebab kita tak tahu R ni besar mana. Okay. Right, so summary of oxidations of alcohol. Kalau primary, kita asingkan jadi strong dengan mild. Kalau strong dapat carboxylic acid, mild dapat aldehyde. Kalau secondary, both got ketone, tertiary got no reactions. So kenapa kena tahu this product, kena tahu observations and stuff ke nanti? Sebab soalan boleh bagi awak informations about the experiment, the reaction. Okay, lepas tu baru dia tanya, mungkin dia bertanya awak, from the observations given, what is the class of alcohol? Awak kena suggest structure. Kalau awak tak tahu produk yang dapat pada mana, awak tak bolehlah suggest dengan betul sama ada dia primary, secondary or tertiary alcohol. Yeah? Okay, next, identification test. So this identification test, untuk bezakan, dia ada beberapa. So dia nak bezakan antara classes of alcohol. Okay, ada 2 jenis test yang kita akan belajar. One is Lucas test. So Lucas test is used to distinguish primary and secondary from tertiary alcohol. Okay, kenapa dia kata primary and secondary from tertiary alcohol? Nanti kita akan tengok dia punya observations. And then Lucas test is used to distinguish primary and secondary alcohol from other compounds juga, except for aldehyde. Okay, bila dia kata except for aldehyde, maksudnya aldehyde akan bagi positive result juga. Nanti kita akan jumpa lagi dekat dalam chapter 9. Okay, dia bolehlah kiranya kalau awak ada alkohol dengan alkin. Kalau awak pilih Lucas test, awak akan dapat positive result dekat alkohol. Dekat primary alcohol contoh. Dekat alkin dapat negative result macam tu. Kalau awak nak jadikan alkin positive result, awak ambil lah bromine in water. Kalau bromine in water, Lucas test dapat negative result. Primary alcohol dapat negative result. Macam itulah. Okay, ada 2 function. Kalau iodoform test pula, dia bukan untuk distinguish primary, secondary and tertiary. Dia nak detect the presence of methyl carbinol. So what is meant by this methyl carbinol? Okay, so we initially have this carbon got 4 bonds around it, kan? Okay, when you have this carbon attached to it is OH and H here, ada ni, kita panggil dia carbinol. Okay, carbinol group. So, Attached to this carbonyl group, we have methyl on them. Jadi, kita nak check ada tak methyl carbonyl ni dalam struktur awak. Kalau dalam struktur awak ada methyl carbonyl ni, dia akan bagi positive results in iodoform test. Boleh? Methyl carbonyl. Nanti chapter 9 awak jumpa methyl carbonyl. C double bond O pula. Attached to it CH3. Yang ni COHH attached to it CH3. Okay awak?
Boleh, Miss.
Okay.
Okay, Miss.
So kita tengok Lucas test sebab kita nak distinguish between primary, secondary and tertiary. Lucas test ni dia punya reagent adalah concentrated HCl plus zinc Cl2. Okay, so this is how you write your reactions. Concentrated HCl over to form ni ada zinc Cl2. You want to substitute ROH to become RCl. Okay, R ni belongs lah dia primary, secondary or tertiary. Depends pada species awak. Okay, so saya tak buat dia punya reaction, tapi kalau reaction contoh awak ada secondary alcohol, awak kena lukis lah secondary alcohol, produk pun yang dapat pada secondary alcohol. Basically dia just replace sahaja OH dengan Cl. So sepatutnya tak ada masalah untuk tulis produk. Dan bila melibatkan test, side product kena include. Tak ada side product kira salah chemical equations together with the conditions here. Okay, for type of alcohol primary, the observations, no cloudy solutions formed at room temperature even after 15 minutes. Maksudnya tak form cloudy solution. Kalau secondary pula, dia akan form cloudy solution tapi lepas 5 minit, lambat sikit. And then we have tertiary, cloudy solutions formed immediately. So contohnya, awak ada primary and tertiary aliphatic alcohol to be distinguished. Okay, lepas tu bila awak buat eksperimen, awak nampak no cloudy solutions formed at room temperature even after 15 minutes. So kita boleh kata, oh ini adalah, sebab contoh awak tak tahu primary ke secondary ke tertiary. So awak buat primary dengan tertiary tu, kita tak tahu lagi. Kita tengok yang ni dia kata no cloudy solution, lambat baru dapat. Kalau yang tertiary, memang tak ada lah, sorry. Memang dia tak form cloudy solution, clear je. Kalau tertiary, immediately. So kita dah boleh bezakan, oh ni tertiary, ini primary. Okay, kalau iodoform test, sebab kita nak test, kita nak detect the presence of carbinol, methyl carbinol. So kita akan ada this alcohol. Make sure you have this methyl carbinol. Okay, with these reagents of excess I2, OH minus. Okay, you will get this kind of product. So methyl carbinol ni methyl carbinol, dia akan cleave. Bila dia cleave, dia akan dapatkan this product, carboxylate ion. So apa yang dia buat dekat sini, bila dia cleave, dia akan dapat double bond O kat sini. Okay, lepas tu yang CH3 ni, dia pergi ambil I dekat sini. So dia akan jadi CHI3. So this is iodoform. You have carboxylate ion dan juga iodoform as your product. What does this arrow means? Arrow pointing downwards. Maksudnya kita form apa?
Precipitate.
Precipitate. So the observations for this iodoform test, if you got iodoform, maksudnya positive results, you will have light yellow precipitate formed as your observations. Now kita akan cakap specifically for aromatic alcohol, which we call them as phenol. Okay, phenol is this class of compound. It's different from aliphatic alcohol. Tetapi group, functional group dia tetap sama, hydroxyl group. Alright, so for phenol, okay, we have this one feature, the physical properties yang kita akan belajar, iaitu acidity. So what is meant by acid? Apa yang awak faham daripada perkataan acid? We have learned about this in chapter 7 last semester. What do you recall about acid? Kalau kata acid ni kenapa?
H plus.
Kuasa.
H plus.
Yes, H plus. H plus tu yang kiranya kita nak dissociatekan H plus, right?
Yes.
Yes, miss.
Yes. So untuk dia dissociate H plus, dia kena able to donate the H plus, which in this case the proton. So acidity ni dia bukanlah berlaku pada benda yang namanya acid saja. Any organic molecule yang ada acid character yang boleh donate a proton. Okay, an acid is a molecule or ion capable of either donating a proton. Okay, kita tahu kita nak releasekan H plus tu. Okay, bila kita nak release H plus ni, kita akan tengok banyak compound. Kita tahu kalau acid, carboxylic acid sahaja. But at the moment, we are talking about alcohol. Okay, alcohol still carry the acid character from the H. Okay, jadi kita nak tengok juga nanti, dan awak untuk chapter 8 ni, kita belajar very basic dulu. Lagi detail tentang acidity in chapter 10, carboxylic acid. Sebab kita dah jumpa banyak compound. Okay, tapi saya nak cakap dah siap-siap. Untuk setiap acidity of a compound, dia akan berlainan. Kenapa dia berlainan? Dia ikutlah reactivity dalam compound tu. Apa factors affecting dia. So, untuk determine strength of acidity, the strength of acidity of a compound, kita akan tengok the ability for the H on the OH to be donated. Kita nak donatekan H pada OH tu. Kalau awak tengok carboxylic acid pun ada OH. Okay, so nak ambil H sahaja daripada OH. Untuk dia able to donate H ke tak, kita kena tengok juga the group that hold the hydrogen. Okay, the group that hold the hydrogen usually from organic compound, it comes from carbon. The carbon, kalau nak senang remove hydrogen, the carbon kena kuat ke kena lemah?
Lemah.
Sekarang ni kita nak remove hydrogen dengan senang. Awak nak buang dengan senang. Kalau nak buang dengan senang, maksudnya the opposite group tu kena
Kuat.
kena kuat. Dia sama Wak macam kita belajar dalam chapter 4 hari tu, chapter 5 hari tu, the reactivity untuk free radical tu. Ingat tak? The more easier it is to be donated. Samalah case ni sebab kita nak pecahkan bond tu.
Okay.
Okay, faham Sebab lagi senang kita nak remove, bila kita senang, dia punya difference in terms of electronegativity tu tinggi. Jadi untuk dia difference, dia kena, kalau yang ni lemah, yang ni kena kuat. Sekarang ni kita nak senangkan remove hydrogen. Bila nak senang remove hydrogen, the bond between carbon dengan hydrogen tu, bukan O dengan carbon tu, dia kena kuat. Bukan kuat, sorry. The carbon tu kena kuat, yang H ni kena lemah. Jadi itulah nak tengok group apa. Sebab kita deal with alkyl group. Okay, so bila sebut ability untuk hydrogen to be donated, nak tengok senang ke susah, kita akan tengok the stability of the conjugate base, the carbon that hold the OH tu. Right. So untuk case alcohol ni, kita akan tengok pada compound yang ada OH. Okay, the first one we're gonna look at the water. So water got OH in here. Aliphatic alcohol, you have open chain alcohol, ada OH juga. And then phenol, sebab kita nak tengok the aromatic alcohol macam mana dia punya reaction, kita ada OH juga. So boleh tak dia orang semua ni ada acidity feature? Bila dia ada OH, boleh tak dia bawa karakter acid tu?
Can.
Can, sebab kita tahu acid tu tadi adalah dia able to donate the H ni. Okay, boleh And we know from the definitions of acid itself, kita belajar chapter 7 dulu, kita nak dissolve completely in water, is it? Maksudnya dia nak dissociate pun dengan water. Means you're gonna have another water molecule to be attracted to this water molecule kita. Sebab definition dia kata substance that is completely or partially dissociate in water to release hydrogen, is it? Do you still remember the definitions of acid?
Yes, Miss.
Yeah, so sekarang ni siapa yang nak pergi ambil hydrogen tu sebab dia kata nak easier or difficult to be donated adalah water molecule jugalah sebab kita tengok definition acid. So apa yang kita akan buat dekat sini? The lone pair will take the hydrogen and then break the bond between this H and O. And lastly, you will get OH minus and also H3O plus. Maksudnya hydrogen yang di-donated tadi dia dah jadi H3O plus dekat sini. So kita dapatlah satu acid, satu base, betul tak? Plus dengan negative charge. Okay, Wak?
Yes.
Alright, so from these dissociations kita akan dapat this Ka value. So this Ka value indicates the dissociations of the acid. So kalau ada Ka, maksudnya dia weak ke dia strong?
Weak.
Dia macam weak lah, tapi kita tak ada pun nak cakap dia weak ke strong ke, kita still kena tengok value sebab semuanya akan ada Ka value sendiri. Alright, so daripada interactions between water molecule and the substance yang kita nak, kita akan dapat this hydroxide ion. So we gonna look at the acidity on this hydroxide ion untuk water. And then we have this aliphatic alcohol dissolved in water, okay, to release hydrogen plus. Hydrogen plus kita dalam bentuk H2O plus lah. Dan kita akan dapat alkoxide ion. So acidity of this aliphatic alcohol akan depends on the alkoxide ion. And lastly, phenol, we want to take the hydrogens from the oxygen, break the bond, then you will get this intermediate of phenoxide ion. Okay, can I know what are the similarities between these three compounds?
Charge of oxygen.
Sorry? They got,
Charge of oxygen atom.
yeah, they got oxygen atom, good. Tapi this is no longer an atom. This is now an
Ion.
ion.
Charge.
So, yeah, semua orang ada negative charge, right? Betul tak? Semua ni ada
Yes.
negative charge. So, bila negative charge, they are electron rich or electron deficient species.
Rich.
Bila electron rich, bila electron rich, adakah factors affecting the stability akan sama macam awak belajar dalam carbocation? Carbocation electron deficient kan?
Betul.
Okay, bila dia carbocation deficient, untuk dia stabil, dia kena yang electron donating group yang kena stabilize dia. Tetapi kalau this electron rich species, dia tak nak electron donating group duduk dekat dia sebab dia dah cukup kaya. Nanti dia lagi tak stabil. So, kita akan tengok stability of your conjugate base sama macam trend carbo and ion. Macam siapa?
Electron rich.
Yes,
And
dia
ion.
electron rich. Jadi kita akan tengok trend sama macam carbo and ion. Do you still remember carbo and ion is negative charge carbon. So they got rich in electron in here. The electron density is very high. And then if you have alkyl group which act as an electron donating group, dia akan keep on bagi elektron. Bila dia keep on bagi elektron dekat spesies yang dah kaya dengan elektron, dia akan jadi makin stabil atau tak stabil?
Tak.
Stabil. Okay, so kenapa kita kata tak stabil? Awak boleh tengok dekat Ka value. This Ka value indicates the acidity of each of this compound. Could you please tell me who's got the highest acidity out of these three compounds?
Phenol.
Phenol. Phenol got the highest acidity, followed by
Water.
water, followed by
Aliphatic alcohol.
alcohol. Kenapa awak rasa phenol got the highest acidity? Padahal dia ada this alkyl group kan?
Value of Ka.
Sebab dia ada alkyl group, yang ni pun ada alkyl group tapi dia rendah, ni tinggi. Kenapa? Yang ni lah kita nak discuss dalam this subtopik. Tapi faham kan konsep ni? Bila dia ni dah rich in electron, kita akan tengok stability dia dekat group attached to it. Group attached to it tu will have to increase the stability or will destabilize the compound. Okay, kalau kita tengok value dia ni 10 power of negative 14, 10 power of negative 16. Kita tengok alkyl group got so many electrons on them. They will keep on giving to this O minus. While hydrogen got only one electron. Bila dia bagi pun tak effect sangat. Sebab itulah acidity of water is higher than that of aliphatic alcohol. Okay, so dia punya trend phenol is the highest, followed by water, followed by aliphatic alcohol. So what's the explanations behind this trend? Okay, phenol is the most acidic because the phenoxide ion formed is stabilized by resonance effect. Okay, this resonance effects comes from the benzene group. Okay, do you still remember your chapter 6, benzene? So in benzene, we know that benzene is aromatic compound. So aromatic compound got 4 criteria to be obeyed in order for them to become aromatic ring. First is cyclic, second is planar, third is completely conjugated. Okay, on this third factor, the completely conjugated that allow this phenoxide ion to have this resonance effect. Do you still remember what is meant by resonance?
Yes.
Yeah, resonance basically you movekan the pi electron, right?
Yeah.
Yes.
So by having by having an alternate double bond and single bond, you can move the pi electrons to the next carbon. You can move them around. So bila dia ada this resonance effect, nanti kan saya akan tunjuklah dia punya gambar raja. Asalnya kat sini. Asalnya here you will get this O negative, right? So this O negative got extra electron, they will give some to here. So dia akan buat double bond. And then kita akan ada sini pula, kita donate pula kat sini, pecahkan. Nanti dia akan bergerak kat dalam. So bila awak punya electron keep on moving around the ring, maksudnya lagi lama lah kan elektron tu berada di situ. Dia tak adalah immediately nak bagi. So dia jadi kuat lah sebab dia keberadaan dia lama dekat dalam ni. Dia berlega-lega. Dia tak terus bila ambil terus dia lemah, tak. Sebab tu kalau yang macam ni dia keep on bagi, yang ni elektron keluar daripada dia, bergerak ke sini, bergerak. Kalau macam alkoxide ion, kita kata dia electron donating group, right? So dia akan giving electron macam ni, betul?
Betul.
So bila dia bagi, keep on bagi, dia jadi tak
Okay.
stable. Yes. Kalau phenoxide ion kan, kalau phenoxide ion walaupun kita banyak karbon dalam ni tetapi dia bukan alkyl group yang akan jadi electron donating group sebab dia ada this completely conjugated punya feature. Okay, dia akan gerakkan this double bond ke sini, this lone pair ke sini. Nanti dia buat double bond. Lepas tu nanti dia bergerak ke sini. Dia bergerak ke sini. Dia bergerak ke sini. Bila dia bergerak, elektron makin pergi ke arah O atau away from O.
Away.
Away kan? Bila away, dia akan stabilize or destabilize the phenoxide ion?
Stabilize.
Stabilize lah. Okay, kita tak nak electron keep on moving to the O negative. We now want to distract the electrons from moving to the O negative. So kita akan bawa dia keluar. Tapi dia bukan keluar terus. Dia berlega-lega lama sikit kat situ. Sebelum dia nak sampai balik. Macam tu lah. So dia positif negatif lah. Alright. Okay, so kalau untuk explanation phenol macam tu lah, kita cakap dia the most acidic because this phenoxide ion. You must emphasize the name of ion when explaining about the trend. No longer phenol ke water ke aliphatic alcohol because the acidity rely on the ion you have formed. Sebab kita tunjuk tadi how we form the acid. Acid means you dissociate you release the H plus tu. Okay, jadi sebab tu kena guna phenoxide ion. Kalau hydroxide ion datang pada water. Okay, kena bagi tahu lah this resonance effect ni. Tak payah cerita pun yang nak dia bergerak-gerak tu ke apa. Resonance effect kita dah faham. Dia akan gerakkan pi electrons. Okay, hence bila kita cakap dia most acidic, jangan stop sampai dah compare habis. Kita kena cakap bila dia most acidic, maksudnya conjugate base dia paling stable. Jadi senanglah untuk hydrogen to be donated. Okay ni untuk phenol.
Faham.
Okay, faham. Untuk aliphatic alcohol and water macam saya cakap tadi lah. Aliphatic alcohol has lower acidity than water due to alkoxide ion is destabilized by the presence of alkyl group which act as an electron donating group. Okay, water ni bukan dia tak ada yang donate elektron kat dia tapi hanya hydrogen. Kecil lah compare to alkyl group. Okay, now yang ni yang saya nak tunjuk. The resonance stabilized phenoxide ion. So, apa yang dia boleh buat? Spread the negative charge over 4 atoms rather than concentrated it on just one atom produces more stable ion. Sebab dia tarik elektron tu daripada oksigen. So, tak adalah dia terburu-buru nak pergi attack orang lain. So, we'll start from here. Kita akan donate the lone pair, dapatkan double bond. Tapi bond dekat sebelah dia kena pecah. Dan perasan tak? Dalam benzin kita bagi dekat bond sebab kita nak jadikan double bond kan?
Yes.
Tetapi sebab uranium ion adalah positive charge. Now we are talking about negative charge. Bila negative charge, walaupun awak gerakkan dia, dia masih rich in electron. Uranium ion hari tu kurang elektron sebab tu dia positif. Bila kita gerakkan more electron, maksudnya elektron yang ada lebihan, kita tak akan bagi dekat bond. Kita akan bagi dekat edge of the carbon. Okay, sebab awak masukkan 2 elektron ekstra. Asalnya dia stable. Takkanlah tiba-tiba dalam ni dia pun stable. Dia mesti ada lebihan juga. Jadi sebab tu dari bond pergi ke bucu carbon ni. Pointing towards the bucu. Okay, bila kita pointing towards the bucu, kita akan dapat double bond between carbon and oxygen. And then we have extra electron on here denoted by negative charge. Kena tunjuk the extra lone pair together with negative. Sebab dia ada lone pair lah, dia negatif. Kalau dia tak ada lone pair, dia positif, dia kurang. Okay.
Okay, Miss.
Okay.
Right. Okay, lepas tu kita akan gerakkan dia. Okay, gerakkan dia, dapatkan double bond sini. Dapatkan double bond, lepas tu kita akan gerakkan dia pergi ke bucu yang ni pula. So, nanti dapatlah yang ni pula kan. Lepas tu yang ni boleh lagi tak gerak? Kita tak ada buat belah sini lagi kan? Boleh tak kita gerakkan dia?
Boleh.
Boleh. So kita masukkan balik sini. Lepas tu yang atas tu dia kena bagi balik dekat sini. Lepas tu kita akan gerakkan for one last time. Sebab kita tak ada lagi yang belah sini. Kita gerakkan dia masuk dan dia akan kembali jadi O negatif. Boleh? Faham tak? Barulah bila dia dah sampai balik, baru dia boleh pergi attack orang. Itu yang membuatkan dia stabil. Kalau negative charge tertumpu dekat O minus sahaja, dia susah nak lepaskan hidrogen kat tepi tu. Bila dia berlegar-legar, dia dah senangkan hydrogen to be released.
Okay.
Okay, right. Okay, so kita tengok sikit example dalam ni. So we have a number of compound. Starting from the left, is this an aromatic alcohol?
No.
No.
Oh, this is simply apa? Apa nama dia ni? Boleh tak bagi nama dekat saya?
Aliphatic alcohol.
Okay, this is aliphatic alcohol. What is the name of this compound?
Hexanol.
Hexanol je. Dia ada cyclic structure.
Cyclohexanol.
Yes, cyclohexanol. So this is
Cyclohexanol.
this is walaupun dia cyclic structure, dia adalah aliphatic alcohol. Jadi lain aliphatic alcohol kita akan treat dia sebagai R macam tadi. Okay, lepas tu here, is this an aromatic compound? Aromatic alcohol?
Yes.
You sure? Check properly. This is benzene, right? But is this benzene directly attached to your O?
No.
So they are not aromatic compound. They are basically aliphatic alcohol, is it?
Yes.
Yes. Now this benzene act as your substituent. What is the name of this compound?
Phenol.
Phenol.
Phenol. Name dia? Nama dia apa? Methyl.
Phenoltanol.
At carbon number?
1.
One should be here. One should be the one that hold the OH. So 2 phenyl ethanol.
Phenol.
Yes, 2 phenyl ethanol. Okay, good. What about this one? Is this an aromatic alcohol or aliphatic alcohol?
Aliphatic.
Aliphatic. Sebab kita ada satu atas ni. Nama dia?
Methanol.
Yes, phenyl methanol. Okay, lastly we have this phenol lah. Okay, who do you think got the highest acidity?
Phenol.
Phenol. Okay, phenol will be the highest, will be the most acidic, and then followed by siapa? Out of the two ring here, siapa yang paling lebih acidic? Now the similarities between these two is resonance effect. So in terms of resonance effect, dua-dua dah menang lah, betul tak?
Betul.
Okay, now look at your alkyl group attached
Betul.
here. What's the difference between these two?
Number C. of carbon.
Number of carbon. When you have bigger alkyl group, means more electron to be supplied, right?
Yes.
By
Yes.
having bigger alkyl group, will they stabilize or destabilize your compound? Will destabilize your oxide ion?
Destabilize.
Stabilize. Sebab tu, bila ada satu sahaja carbon, dia lebih tinggi acidity
Acidic.
daripada yang dua ni. Boleh faham dua ni? Yang ni?
Boleh.
Okay. And then this one, dia akan jadi the last one. Sebab apa? Dia tak ada resonance effect kan? Dia tak ada langsung. Ni kan walaupun dia resonance effect dia bukan directly attached to O, tetapi somehow dia akan affect juga. Okay, dia tolong jugalah gerak dia tapi jauh sikit lah. Kalau yang macam ni, dia directly attached kan. So dia tak ada langsung resonance effect. Dia solely alkyl group. Okay, jadi dia akan jadi yang paling rendah. So nanti kalau awak belajar dalam carboxylic acid, akan jumpa lagi lah acidity ni. Dia kena ada timbang-timbang balik sikit lah. Mungkin dia ni ada, dia ni tak ada. Tengok pula yang different factors. Okay right? So kita kalau nak tengok acidity ke nanti nak belajar basicity, kita tengok resonance effect dan juga group attached to it. Nanti awak akan diperkenalkan dengan electron withdrawing group pula dalam basicity. Okay, tapi for now kita belajar acidity, kita tahu yang resonance effect dan juga size of your alkyl group tu that will affect your acidity. So from cyclohexanol to this 2-phenyl ethanol to phenyl methanol to phenol, acidity increases. Okay, and then for chemical properties of phenol pun berlainan daripada chemical properties of alcohol. Dekat alkohol dia boleh terjadi. Dekat phenol mungkin tak boleh jadi, mungkin yang boleh. So, the first reactions involving phenol adalah reactions with Na. Ada tak this reaction dengan aliphatic alcohol?
Yes.
Yes, so bila dia ada, maksudnya dia phenol pun boleh bagi positive result, alcohol biasa pun boleh bagi positive result. Jadi reactions with Na occur on both lah aliphatic and aromatic. So kalau kita tengok, kalau phenol dapat this product, cyclohexanol iaitu aliphatic alcohol pun dapat this product. So untuk reactions with Na sama. In contrast to second reactions, we have reactions with sodium hydroxide. Sodium hydroxide also got Na, but do we have these reactions in aliphatic alcohol?
No.
No, jadi boleh tak kalau contoh reactions with NaOH dalam satu compound awak ada aromatic alcohol and aliphatic alcohol. Dia akan happen at both side ataupun salah dekat bahagian aromatic sahaja.
Aromatic only.
Aromatic saja.
Aromatic only. So hati-hati walaupun awak nampak NaOH hanya reactive towards phenol. Okay, so phenol ni sebab NaOH ni dia adalah aqueous NaOH. Okay, dan kita tahu kalau alkohol yang more than 5 carbon dah dia tak boleh nak soluble dah. Itulah dia punya reasoning. So kita akan dapat instead of H2 kita akan dapat water because it comes from here OH. Sebab kita akan take hydrogen from phenol, we take OH from the sodium hydroxide, then we'll get this salt O minus Na. Okay, bila awak ada aliphatic alcohol to react dia insoluble, dia tak boleh buat reactions. Okay, last untuk kita punya kelas hari ni, kejap je. Identification test. So this identification test is to differentiate usually between aliphatic and aromatic alcohol. If you are given aliphatic and aromatic alcohol, you can simply choose whether you want to use this test yang listed under phenol ataupun listed under aliphatic alcohol. But preferably if you are given aromatic and aliphatic, just go for aromatic alcohol punya test. Lebih senang.
Boleh, Miss.
Okay, so we have two identification tests for phenol by using FeCl3 solution. Okay, so phenol will react with the aqueous solutions of iron 3 chloride. So iron 3 chloride ni adalah FeCl3 in aqueous state. You initially got this phenol to react with and then you will get again phenol, but now this FeCl3 sebab dia adalah transitions metal, dia akan be in between this ring. Okay, purple complex. So bila purple complex ni dia gives the observations. So observations for this test, any test mesti ada observation. Purple complex form, itu sahaja. Kalau awak nak bezakan phenol dengan cyclohexanol using FeCl3 solution, observation untuk cyclohexanol akan jadi apa?
No changes, Miss.
No apa? Observation.
No observable changes.
Oh, itu kalau dalam chemical equation. Kalau chemical equation kita tulis no observable change. Tapi dalam observation, awak kena follow the positive result. Kalau positive observation cakap purple complex formed, kalau dia bagi negative result, awak kena cakap no purple complex formed. Macam tu.
Okay, Miss. Boleh, Miss.
Alright. Yes, lastly kita ada using bromine water. Bromine water ni banyak dalam alkene kita ada. Chapter 6 tak ada, chapter 7 pun tak ada juga. Okay, chapter 8 kita jumpa balik using bromine water. So using bromine water, basically Br2 dengan water sahajalah. Okay, Br2 in polar solvent. Okay, you initially got this phenol. Phenol masih kekal, tetapi bila dia react dalam polar solvent, this polar solvent dia akan bagi auto para. This water solvent, this OH. Okay, nanti awak akan, dulu kita belajar, dulu masa saya belajar. Dia adalah electron dia adalah electron withdrawing group. Bila dia electron withdrawing group, dia akan jadi activator untuk auto para director. Oh, nampak tak? Ni karbon nombor 1 kan? OH ni karbon nombor 1 kan?
Yes.
Yes.
Dia induce Br ni kan banyak kan? Dia induce Br untuk masuk dekat auto dan para direction. Auto 1, 2, para 1, 4. Sebab tu sini pun ada 1, 2. So sebab tu dia akan masuk dekat 2, 4, 6 carbon Br ni. Dia OH adalah auto para director group. Dulu kita belajar. Dan saya rasa batch depan akan belajar balik benda tu. Batch awak dah tak ada. Okay, tapi awak kena hafal lah 2, 4, 6 tak boleh masuk mana-mana. Dia memang this group dia ada dia punya function sendiri. Dia akan masuk dekat auto and para. So 2, 4, and 6. So what is the name of this compound?
2, 4,
6
6. Tribromophenol.
Yes, tribromophenols and also HBr. Bila buat identification test, tolong provide sekali dengan dia punya side product. Okay, dia cakap to form what precipitate. So our observations for this identification test of phenol will be white precipitate form.
2, 4, 6 tribromo.
Phenol. Okay, thank you. Okay lah. So kita dapat white precipitate untuk this reaction. Okay, itu sahaja awak, chapter 8 awak. Thank you everyone. Assalamualaikum.
Miss, thank you Miss.